Hi, you're welcome to my math friend, your favorite math educational channel. In today's lesson, we shall be looking at rationalizing sets, as was notified in the previous videos, okay, on multiplying and dividing sets. So let's move quickly to rationalizing sets. Before we continue, subscribe to the channel if you've not, because you are missing a lot, and hit the notification bell for more. Okay, what does it mean with rationalizing sets? It means the denominator becoming a rational or whole number right from the board. The denominator becoming a rational or whole number. Now, what it means is that right from this rule, you see that the denominator is a set, okay? Good. A out of root B. Root B is a set. So what do we do? The trick is that you multiply both the numerator and the denominator by the what? By the denominator. So A out of root B becomes A over root B times root B out of the same root B, as you see. Now this becomes numerator times numerator. A times root B is A root B. Denominator by denominator also becomes root B times root B becomes B. There's a rule on multiplying sets where we say that root B out of the same root B is B. You remember that code. So visit the video so that you don't get lost along the way. Some examples over here will help you to better understand the topic on rationalizing sets. So follow me. Simplify, leaving your answer as a set. Number 1 out of root 6. Now, the denominator, root 6, denominator is a root, is a set, okay, and 6 is not a perfect square. So we can't find its square root. So we rationalize it, multiply both the numerator and the denominator by the denominator. So this becomes times root 6 out of the same root 6. You see that code? This is equal to numerator by numerator. 1 times root 6 is root 6. Denominator by denominator. Root 6 by root 6 is what? Is 6. And this is our answer. You see that? Very simple. Let's go to example 2. Now, in this question, you have two different fractions, two different sets, okay, which have been added. So you treat them just like when you are adding fractions, okay. Now, this is an expression. There is no equal to sign. So you find the LCM, you write the LCM below under the line. You get it? Good. What is the LCM of root 3 and 3 root 3? You multiply them or put them together, just like that. So we have this 3 outside by what? Root 3 times root 3. Like this. Let's pick the first fraction. Denominator root 3 goes into this very LCM. There is root 3, there is root 3. You see that? So what is left? It's left with 3 root 3. So this 3 root 3 that is left multiplies the numerator 2. 2 times 3, 6 root 3. Goes to the second fraction. The denominator is 3 root 3. Is 3 root 3 here? Yes, it's here. What's left? Root 3 is left. So root 3 that is left multiplies the numerator 2. Okay, so we have 2 root 3. Cool, do you see that? Very simple. The next step, what do we do from here? Now, root 3, there's root 3, there's root 3. These are like sets, so you can add them. Add the numbers outside. 6 plus 2 is 8. 8, you pick one of the roots since they are the same with 3. Out of this, 3 times. Okay, now root 3 times root 3 is what? Is 3. There's a rule on that, multiplying sets. Kindly follow it, please. So it's times 3. What do we do from here? This becomes 8 root 3 out of 3 times 3 is what? 9. So this is the answer. You see that? Very simple. Good. Let's look at the third and the final example of question. In this case, we are multiplying. You see that? Good. Now you're multiplying two different sets. Two different sets. So in this case, what you do is that you check the numbers in the roots, okay, and see that if you can, just like when we're multiplying or when we're simplifying sets, you find two factors of the number in the root. What times what to give it 125, where one of them a perfect square? 25 times 3, replacing the 125. Two factors of 108. We choose 36 by 3. Good. Now from here, yeah, 10 out of root 25 is 5. And root 3 is already simplified. And it's not a perfect square. Leave it like that. Times. Root 36 is 6. 6 root 3. What do we do from this stage? Multiply numerator by numerator. Denominator by denominator. 10, 6 is 60. 60 root 3. Out of 5 root 3. Do we leave our answer like this? No. Why? Because the denominator is in its acidic form. Okay, so because of that, this is where we what? We rationalize this very set. Now let's look at how to do that. You multiply both the numerator and the denominator by the denominator, which is 5 root 3. So this is times. Good, you get it. So simple. Numerator times this 5 root 3. Denominator 2. Denominator, this denominator 2 times this same 5 root 3. That's how to rationalize sets. That is the trick, rationalizing sets. Good. What happens in this stage? Somebody say you want to cancel. No, you don't cancel. You don't say 5 goes, you don't cancel this way. You do that, you come back to this single set you had first. You get it? Good. So what do you do at this stage? Numerator by numerator, denominator by denominator. 60 by 5 is what? 300. Root 3 times root 3 is what? It's root 3. It's 3. 5, 5, 25. 25 by what? Root 3 times root 3 is 3. Now from here you can cancel. You see that the denominator has changed and become what? A rational or a whole number, like we said over here. So what do we have? 25 goes to 25, 5 into 6 into 360 goes into itself 112. That's just to say 25 goes into itself 1 to 312. You see that? So the answer over here is 12. And that is the answer. Very, very simple. Good. Now I want you to follow the lesson, okay, step by step, and understand it. Good. You can leave your question in the comment section and I'll address it for you very well. Follow me in the next lesson or video on a further question on the same topic, rationalizing sex. Bye.